December 9, 1944. The frozen mud of the Ardennes forest crunched beneath Hauptmann Ernst Becker's boots as he approached the massive artillery piece, sitting silent and abandoned in a small clearing near Malmedy. Dawn had barely broken, and the fog hung thick between the snow-laden pines. Around him, his battery crewmen of the 2nd Panzer Division's artillery battalion gathered in a semicircle, their breath forming clouds in the bitter cold. The gun before them was enormous. Even for men accustomed to Germany's heaviest artillery, this American weapon was staggering. Its barrel stretched nearly 24 feet long, suspended on a carriage that seemed impossibly sturdy, yet somehow mobile. The metal gleamed dully in the morning light, coated with a thin layer of frost. Stenciled on the breech in white paint were the words, M1 155mm, Gun, U.S. Army Ordnance. Ernst had seen plenty of captured equipment in his 4 years of war. French 75s, British 25-pounders, even some Soviet pieces. But this was different. The Americans had abandoned it during their chaotic retreat 2 days earlier, leaving it intact with nearly a dozen shells still stacked nearby in wooden crates. His orders from divisional command were simple. Evaluate it, and if possible, turn it against its former owners. Sir, called out Feldwebel Otto Kranz, the battery's chief mechanic, running his hand along the breech mechanism. I've never seen construction like this. Look at the tolerances. Look at this machining. Ernst moved closer. Otto was right. Every surface was smooth, every joint precise. The Germans prided themselves on engineering excellence, on the craftsmanship of Krupp steel and Rheinmetall's designs. But this American gun possessed something else entirely, not artistry, but industrial perfection. It was built not by master craftsmen in a workshop, but by machines in a factory, stamped out with a consistency that was almost unsettling. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The crew began their inspection systematically. Gefreiter Hans Müller, the youngest of the gunners, climbed onto the carriage to examine the elevation mechanism. Hauptmann, the traverse is hydraulic, and there's a recoil system I don't recognize. Ernst nodded slowly. German artillery of this caliber typically required complex manual adjustments. The legendary 88mm flak gun was effective, yes, but it demanded constant physical effort from its crew. The 150mm SFH-18, Germany's standard heavy field howitzer, could throw a shell roughly 9 miles with accuracy. This American piece, if the intelligence reports were accurate, could fire more than twice that distance. But intelligence reports were often wrong. Propaganda, even. The idea that any gun could accurately hit targets at 25 miles seemed absurd. At that range, the curvature of the Earth itself became a factor. The shell would be in flight for nearly a minute. Wind, temperature, even the rotation of the Earth would influence its trajectory. No, Ernst thought, the Americans were probably exaggerating. They always did. Let's see what's in those crates, Ernst ordered. 2 men pried open the nearest ammunition box. Inside, nestled in protective packing, were shells unlike anything the Germans had seen in standard use. Each projectile was enormous, a 95-pound high-explosive round, painted olive drab with yellow markings indicating the explosive type. The brass cartridge cases gleamed, perfectly formed, without a single defect visible. Otto lifted one shell carefully, examining the rotating band, the copper ring that engaged the rifling inside the barrel. This copper is of exceptional quality. And the machining on the shell body. Hauptmann, these aren't hand-fitted. These are mass-produced to exact specifications. That word again. Mass-produced. It was becoming a theme, a recurring reality that German soldiers were encountering across every front. At Normandy, American tanks had poured ashore in numbers that seemed impossible. In Italy, Allied artillery had blanketed entire valleys with shells. Now, here in the frozen Ardennes, even a single abandoned gun revealed the staggering scale of American industrial capacity. Ernst had graduated from the artillery school at Jüterbog in 1939, trained in the Prussian tradition of precise calculation and disciplined fire control. He had fought in Poland, in France, in Russia. He understood artillery as both science and art, but what he was looking at now represented something beyond traditional military thinking. This was artillery as mass production, as industrial warfare incarnate. "We'll test fire it," Ernst announced. "2 rounds. I want to see if the Americans' claims have any truth to them." His crew exchanged nervous glances. Test firing an unfamiliar weapon was dangerous under any circumstances, but they were veterans, and curiosity overcame caution. Within an hour, they had positioned the gun, studied its firing tables conveniently left in a waterproof case attached to the trail, and prepared 2 shells for firing. The firing tables themselves were revelations. Printed on high-quality paper, laminated for weather resistance, they contained more data than Ernst had ever seen for a single weapon system. Range tables extended out to 25,000 yards over 14 miles, with corrections for temperature, air pressure, even the direction of fire relative to the Earth's rotation. The Americans had calculated everything, systematized everything. "Target?" Otto asked. Ernst studied his map. 3 miles to the west was a small ridge where American forces had established an observation post before retreating. It was abandoned now, confirmed by scouts. More importantly, it was well within the gun's supposed range, even at a conservative estimate. "Grid, reference 4732118, Ernst said. "Range, 5,000 meters. Charge 3. The crew worked with practiced efficiency, despite the unfamiliar equipment. They loaded the shell, set the elevation, and adjusted the traverse. The hydraulic systems moved smoothly, almost effortlessly. On a German gun of this size, the same adjustments would have required multiple men straining at hand wheels. "Ready, Hauptmann," Otto reported. Ernst stepped back, pulled the lanyard, and the long tom fired. The sound was colossal, a deep, earth-shaking boom that echoed through the forest and sent snow cascading from nearby trees. The recoil system absorbed the blast perfectly, the massive barrel sliding backward in its cradle before smoothly returning to battery position. No realignment needed, no frantic adjustments. The gun was ready to fire again immediately, but it was the impact that truly stunned them. Through his binoculars, Ernst watched the ridge 3 miles away. Exactly 21 seconds after firing, a plume of earth and snow erupted precisely on target. The explosion was massive, far larger than he'd expected. The high-explosive shell had detonated with devastating effect, creating a crater easily 20 feet across. "Gott, I am Himmel," Otto whispered. First round, dead on target. The crew stood in silence. First-round accuracy at 3 miles was difficult even with the best German guns after careful ranging shots. This American piece had done it effortlessly, using firing tables and calculations that accounted for every variable. "Load the second shell," Ernst ordered quietly. "Maximum range. I want to see how far this weapon can actually shoot." This time, they consulted the firing tables more carefully. The maximum listed range was 25,000 yards, 23,000 meters, roughly 14 miles. But the tables also contained notes for extreme range firing, with reduced accuracy, extending beyond 25 miles under optimal conditions. Ernst chose a target 15 kilometers away, 9.3 miles, a crossroads visible on his map, where German intelligence had reported abandoned American vehicles. It was an ambitious shot, well beyond what any German field gun could attempt with reliability. The crew made the adjustments, the barrel elevated to an angle that seemed impossibly steep. The powder charge was increased. Every calculation was checked and rechecked against the American firing tables. "Ready," Ernst fired. This time, they couldn't observe the impact directly. The distance was too great, the terrain too heavily forested. But they had radioed ahead to a forward observation post, and 38 seconds after the shot, the radio crackled to life. Impact confirmed. Direct hit on crossroads. Estimate accuracy within 50 meters of target center. The crew erupted in disbelief. Otto actually laughed a short, bitter sound. 9 miles. 9 miles, and it hit within 50 meters. Hauptmann, our best guns can't do that at 3 miles. Ernst said nothing. He was thinking about the implications, calculating in his head what this meant. The Americans hadn't just built a gun with impressive range. They had created a complete system, the weapon, the ammunition, the firing tables, the mathematics, all working together with industrial precision. Every component manufactured to exact standards, every variable accounted for, every detail systematized. This wasn't just superior technology, this was a different philosophy of warfare entirely. Hans, the young gunner, spoke up hesitantly. Sir, if the Americans have hundreds of these guns, if they can hit us from 9 miles away, beyond the range of anything we have. He didn't finish the sentence. He didn't need to. Every man there understood. The Germans had always prided themselves on tactical superiority, on the skill of their crews and the quality of sighting, their training. But skill meant nothing if the enemy could destroy you from a distance you couldn't even reach. Ernst walked around the gun slowly, studying it from every angle. The long tom weighed nearly 30,000 pounds, yet the Americans had made it mobile. The split-trail design allowed for rapid emplacement. The carriage could be towed at highway speeds by their trucks. German heavy artillery of comparable size required extensive preparation to move, often taking hours to disassemble and reassemble. How many of these do you think they have? Otto asked quietly. Ernst had seen the intelligence reports. They weren't classified at his level, just depressing. Thousands, he said flatly. American factories are producing them by the hundreds each month, along with everything else. Tanks, trucks, aircraft, shells, all of it in quantities we can't match. He pulled out a cigarette, cupping his hands against the wind to light it. The smoke rose in the cold air, dissipating quickly. Like Germany's chances, he thought bitterly. The crew continued their examination of the gun, documenting everything they could. They measured the rifling twist rate, studied the breech mechanism, analyzed the recoil system's design. Every detail revealed the same truth. American engineering wasn't superior in the traditional sense. It wasn't more elegant or more sophisticated. It was simply more practical, more systematic, more suited to mass production. German weapons were often masterpieces of individual craftsmanship. The 88, the Panther tank, the MG-42 machine gun, all represented the pinnacle of engineering art. But each one required skilled workers, specialized components, and time. The Americans had sacrificed perfection for sufficiency, and had produced such overwhelming quantities that it no longer mattered. Ernst had learned in Russia that numbers eventually overwhelmed quality. He had watched entire German divisions, equipped with superior tanks and weapons, ground down by sheer Soviet mass. Now, in the West, the Americans were demonstrating that industrial capitalism could produce the same result with even greater efficiency. Hauptmann. Otto interrupted his thoughts. We should probably destroy this gun before we move out. Division won't want us leaving it for the Americans to recapture. Ernst nodded slowly. Standing orders were clear. Deny the enemy any useful equipment. But he hesitated. This gun represented something he wanted his superiors to see. The war was already lost, he knew that now, even if he couldn't say it aloud. But maybe, somehow, this evidence of American capabilities would help someone, somewhere, understand why. No, he said finally. We document everything. Photographs, measurements, firing test results. Then we send a full report to Army Group B headquarters. They need to know what we're facing. The crew spent the next hour taking photographs with a battered camera they'd requisitioned from a signals unit. They measured every dimension, copied the firing tables by hand, even made sketches of the breech mechanism and recoil system. Ernst wrote a detailed report describing their test firings and the implications for German defensive planning. As they worked, American artillery began to sound in the distance. The counter-offensive was beginning. The brief German advantage gained in the opening days of the Ardennes offensive was already evaporating. Within hours, they would need to abandon this position, retreat deeper into the forest, away from the American advance. Ernst took one last look at the Long Tom before his crew prepared to move out. In another timeline, in another war, this would have been a trophy. Evidence of German tactical superiority, capturing the enemy's finest weapons. But standing here in December of 1944, it felt more like an epitaph, a monument to the kind of warfare Germany couldn't win. The Americans would retake this position within a day, or two. They would recover their gun, clean it, and put it back into service. And it would fire again, accurately, reliably, as part of a vast industrial machine that Germany had no hope of matching. "Move out," Ernst ordered. His crew packed up quickly, loaded their equipment onto half-tracks, and disappeared into the forest. Behind them, the Long Tom sat silent once more, waiting for its rightful owners to return. Above, the clouds were gathering. Snow began to fall again, slowly covering the massive artillery piece in a blanket of white. The report Ernst Becker wrote that day would never reach its intended audience. The courier carrying it was killed in an American airstrike 2 days later, and the documents were lost. But the story of German crews encountering the M1 Long Tom wasn't unique. Across the Western Front, similar discoveries were being made, similar reports were being filed, and similar conclusions were being reached. The gun itself had a history that Ernst and his crew couldn't have known. Development of the M1 155mm gun had begun in the late 1930s, as American military planners recognized that existing artillery was insufficient for modern warfare. They studied European designs, analyzed lessons from World War I, and consulted with British and French experts who understood the realities of industrial-scale combat. The result was the Long Tom, officially designated the gun, 155mm, M1 on carriage M1. The name Long Tom was informal, coined by soldiers who marveled at the weapon's extraordinary barrel length and range. It entered production in 1941, manufactured primarily at the Watervliet Arsenal in New York, though other facilities across America contributed components. By 1944, over 1,000 Long Toms were in service across Europe and the Pacific. Each gun represented not just American engineering, but American industrial philosophy, design for mass production, standardize every component, and produce in quantities that overwhelm the enemy's capacity to respond. The gun's range wasn't its only advantage. The M1 could sustain a rate of fire of 1 round every 2 minutes for extended periods, something German guns of comparable size struggled to maintain. The ammunition was standardized across multiple weapons systems, simplifying logistics. The hydraulic systems reduced crew fatigue, allowing for longer sustained fire missions. But perhaps most importantly, the Long Tom was designed as part of a complete artillery system. It worked in coordination with forward observers, equipped with radio communications, with aerial spotters who could call in precise corrections, with meteorological units that provided real-time data on atmospheric conditions. The Germans had similar concepts, but never achieved the same level of integration and industrial support. In the artillery battles of late 1944 and early 1945, the Long Tom became legendary among both American and German forces. American crews praised its reliability and accuracy. German troops feared its ability to strike from positions they couldn't reach, delivering devastating high-explosive shells with clockwork regularity. Ernst Becker's encounter with the captured Long Tom was just one moment in a larger story, the story of how industrial capacity reshaped warfare in the 20th century. For centuries, military success had depended on tactics, training, and individual valor. But World War II demonstrated that modern war was ultimately decided by factories, by production lines, by the ability to manufacture weapons faster than the enemy could destroy them. The Germans had entered the war with confidence in their tactical superiority and engineering excellence. And indeed, weapon for weapon, tank for tank, the Germans often had superior designs. The Tiger tank was more powerful than the Sherman. The MG-42 had a higher rate of fire than American machine guns. German artillery pieces were often more accurate at comparable ranges, but the Americans had something better than superior weapons. They had superior logistics, superior production, and most critically, the economic capacity to sustain those advantages indefinitely. For every Tiger tank Germany produced, America built 5 Shermans. For every artillery shell Germany manufactured, America produced 10. The mathematics of attrition were inexorable. Ernst Becker would survive the Ardennes offensive, though his battery would be decimated. He would retreat with the remnants of his division back across the Rhine, fighting a series of desperate rearguard actions against an enemy that seemed to have unlimited supplies, unlimited ammunition, unlimited everything. In April of 1945, he would surrender to American forces in the Ruhr pocket, one of 300,000 German soldiers who simply had nothing left to fight with. After the war, in a prisoner of war camp in France, Ernst would meet an American artillery officer who had served with a Long Tom battery in the same sector of the Ardennes. The two men, through broken conversation and shared cigarettes, would discuss their experiences. The American would describe the training process, the standardized procedures, the realization that their artillery support could reach almost anywhere on the battlefield. Ernst would describe that December morning, examining the captured gun, test-firing it, and realizing for the first time what Germany was truly facing. Not just military defeat, but industrial and economic obsolescence. "You know what surprised me most?" Ernst would say, years later, in an interview with a military historian. Not the range, not even the accuracy. It was the consistency. Every shell the same, every gun the same, every firing table calculated to the same standard. That's what we couldn't match. Not genius, not innovation, just relentless, systematic production. The Long Tom would continue serving in the American military long after World War II ended. It saw action in Korea, where its long range proved invaluable in the mountainous terrain. It remained in service with various Allied nations into the 1980s. Even today, examples can be found in military museums across the world, silent monuments to an era when industrial warfare reached its zenith. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this.